Okay, question 3. Now, this is obviously the end of question 2. That's because I want to point out the mistake that I made. It says, here look, it says it wants to know what the range of forces from 3 meters. So it's how's the level of the variation of loudness of the sound from the drum when applying. Okay, so what's happening here is a range of forces from 3 to 9. I mean, it's going to give you a greater range. This is a horrible 2-mark question. I don't like that. It doesn't make any sense to me. Sorry. Basically, we want to talk about range, which makes sense because you've got a greater range of speeds. But this is a bit pedantic. So I would have dropped a mark, which is obviously why I'm moaning about it. But suck it up and move on. Okay, question 3. What we've got is, write down the name of a system that uses liquids to transmit forces. Hydraulic system. To move the platform upwards, the liquid must cause a force of 1,800 newtons to act on the piston. The cross-sectional area is 200. Calculate the pressure in newtons per centimetre squared. So I don't need to do a conversion when the platform moves. Okay, so it's going to be pressure equals force divided by area. Make sure you write down the equation, and then make sure you tell me what goes into that equation. 9. And that's worth the same amount of marks as that one on the previous one on question 2, hence why I was moaning about it. Because that took me, what, 10 seconds? Okay, question C. A new development is using oil from plants as liquid in the machine. The grain when the plants are extracting the oil requires less energy than producing the liquid usually used in the machine. Draw a ring around the correct answer to complete the sentence. Using the oil from the plants gives an environmental advantage over the liquid usually used. Yeah. Odd question. Arguably all 3 are true. But go with environmental because the one that's more justifiable. Okay, so a train travels from town A to town B. Figure 1 shows the route taken by the tram. Figure 1 has been drawn to scale. So town A to town B. You know what's coming next. As soon as you see a line like that with that kind of curve, it's going to be asking you the difference between displacement and distance. The red one I've just drawn, that is the displacement that is between the two. This is the distance travelled by the train between the two. Okay, so part A. The distance the train travels between A and B is not the same as the displacement of the train. What's the difference between displacement and distance? Displacement is distance in a given direction. It is how far from start you end up. Distance is the total number of meters covered in any direction. Now, I don't need to write all of that. Obviously I don't, it's only worth 1 mark. The thing is, I'm not confident of which one of those 3 things that they want as their answer, so I've said all of them. Now, as long as I haven't said anything that contradicts itself, then I won't lose a mark. So as long as I'm consistent, I'm okay. B. Use figure 1 to determine the displacement of the train in travelling from A to B. Okay, and they've given you a nice little scale there. 1 centimetre equals 5 kilometres. So, should really have a ruler. I don't have a ruler. Maybe I do. Now, it's worth remeasuring it because it's been reprographed, so although that says 1 centimetre equals 5 kilometres, it no longer does. So that is 0.8, so 0.8 equals 5 kilometres on this, which means I will then need to do, I would help if I wasn't using inches. I know it's been reprographed better than normal. So that is 1 centimetre. Which means that all I've got to do now is times 7.35 by 5. And I'd write down that that's what I've done as well. And then it's asked for a direction as well. Now, you've got 3 choices here. Well, a couple of choices. We can either work out what the angle is, although how I'm not sure. And the way that you could work out the angle is if you measure these lengths. If you measure this length here and measure this length here, you could then use a bit of trig to work out what that angle there is. I'm not going to do that because I think it's a bit excessive. I'll check the mark scheme to see if you did need to do that. So what have we got? So we've got 7.35 times by 5. 36.75. That's your displacement. It's already in kilometres, so I don't need to convert. And then the direction, well, let's do it properly. Three and a half down. .3 going that way. So if I use silly old hens can't afford houses till old age, I can then use, let's say, well, let's use my hypotenuse because that's one I think I measured the best. I think I measured this downward one better as well, so I think I'm going to go H and O, which tells me I'm going to use sine. So I'm going to use sine theta equals 36.75 over, sorry, with the opposite over that, so that I need to do 3.5 times 5. .5. So 17.5 divided by 36.75 equals 0.47. I then want to do sine of the answer. wants to take the inverse sine. To give me an angle, so if theta equals 0.47 sine to the minus 1, because I just took the sine to the other side, so that equals 28.4 degrees. Now, I think the answer northeast is probably what they're looking for. But if you have time and you know how to do it, then show off and get the degrees in there. And if you are doing the degrees, you probably want to do it from the vertical. So you probably do 90 minus what I just calculated. Or you can just tell it, so 28 degrees from horizontal. Okay, there are places on the journey where the train accelerates without changing speed. Explain how this can happen. Okay, so velocity is speed in a given direction. Acceleration is change in velocity. So you notice that acceleration is change in velocity, not change in speed. So if the speed is staying the same, but it's because the direction is changing. So acceleration at a constant speed is caused by changing direction. D. To gain full marks for showing you worked out the answer, estimate the distance travelled by the train along the section of the journey shown in figure 2. So this is a velocity time graph. Now, if you want the distance on a velocity time graph, then you've got to work out the area under this diagram. Now, you've got a non-constant acceleration, so you've got no other means of doing this. The only way to do it is to come up with a way of allowing you to work out what the area is. So you want to break it down into squares and triangles. So that's my shape 1. That tells me that area there. Okay, so that's 1. So 1 equals 5 times 500. That gives me the area of this section here. So that's 2,500 meters. Because what I'm doing is I'm timesing meters per second by seconds. These 2 seconds cancel out, and they leave me with just the meters. The reason why I've picked this line here for this triangle is because you'll see I've got as much underneath the line as I've got above the line, so the two will cancel each other out. That's what I'm aiming for. Okay, so then I can pick up my shape here, and this one will be number 2. And 2 equals a half, because it's a triangle, base times height. So then it's going to be the difference between 2, so that's 300, times by This bit's a bit trickier. 5. And let's say that's about there. Let's use a ruler. Let's do it properly. Why not, eh? Okay, so if that's 25, 27.5 is there, so that's probably about 28. And then the last one, well, I used the same method that I used previously, where I had a little curve. So I try and draw my line where I think I've got as much above it as I've got below it. So that's probably going to be, what, 28, 29, so around there. So that's going to be area number 3. So that's 100 times by, and I've got to take 5 off it again. So don't, oh yeah, look, 28 there. I forgot to take off my 5 because I didn't start from the start. Apologies. So let's call that 28.5. Maybe 29. Yeah, it's going to be more like 29, isn't it? 29 minus 5, so that takes me. Okay, so calculation. Half times 300 is 150, so I need 150 times by 23. So my first calculation. So 150 times by 23. 3,450, and then I need 100 times by 24, so 2,400. Add the 3 together, so that's 4,900. Add 3,450. Equals 8,350 meters. That's all right. Okay. Might want to do a little sense check on that. So, as a sense check, I would say that it has to be. Let's say that that's from there to there. So let's say that the average speed is roughly 17. That's a bit of a guess. So 17. So 17 times 500 should be in the same ballpark. If it's not in the same ballpark, then I've probably done something wrong. So 17 times 500 equals 8,500. That's pretty damn close ballpark, okay? So I am happy with that as a way of figuring out that I was probably quite accurate.